Hello. I thought it would probably be easier to learn this if it was like a video, so I decided to make one. So I hope you enjoy it, and if you have any questions, feel free to ask me, and I'll do my best to get back to you and stuff like that. Okay. So so we have the steps right here, and we have our P's and our Q's right here. And we have what we're supposed to do right here. Alright, so now it becomes, how do we do it? Well, luckily for us, the P and the Q section right here, they stay the same no matter what truth table you're building. Because P can only be true or false, and Q can only be true or false. So there's only a limited number of things that can be. So they're the same for any truth table. T, T, F, F, T, F, T, F. So that solves that. So, but our first step after that is to determine what the main operation of the statement is. And our statement is Q and the disjunction of P. Okay, so how do we figure out what the main operation of the statement is? Well, it would be very easy if the negation of Q was in parentheses, because then it would mean the disjunction is automatically a statement because it is outside the parentheses. But as you can see, there are no parentheses, so how do we deal with this? Well, if you look at step 2, you see complete the columns of the simple statements and then their negations if they are relevant. And what do we have here? We have a negation. So that means it's not the answer because the answer is step 5. Complete any remaining connectives. So that's how we know that it is a disjunction statement. So we are trying to figure out this little guy, not this guy. So we will need to figure that out. But it will be not the correct. Well, it'll not be the answer. It'll just be a part of the answer. I hope that makes sense. Okay, so now we have P and we have Q right here. Well, luckily for us, we can just scoot the P right over here, and we can just fill it in like so, and that is the correct answer. But now you see, we're looking for the negation of Q rather than Q itself. So we scoot Q over here, and we just negate it, like so. And that is the correct answer for this. And so now the question becomes, how do we find the disjunction? Well, this is not just a simple disjunction symbol. It functions as the statement negation of Q with the disjunction of P. It is that entire statement, but it's just a simplified. I'm sorry, it is just simplified into a basic symbol, but that's what it really means. Okay, so how do we figure that out? Well, what do we know? We know our P's and we know our Q's. So now the question becomes, how do we do this? Okay, so we know that what we're paying attention to is the P right here and the negation of the Q right here to find the disjunction right here. So what do we know? We know P is 3 squared equals 9, and we know Q is 8 plus 4 equals 12. So we know the simple statements are both true. So for the first row, because both statements are true, the negation would be false, but the P would still be true. So how do we do this? Well, we learn that Q as the negation is 8 plus 4 does not equal 12. But P, as it's still true, 3 squared still equals 9. So, basically what this means is we're not saying that 8 plus 4 does not equal 12. We're saying that the statement 8 plus 4 does not equal 12 is incorrect. It's false. But we're saying right here is the statement 3 squared equals 9 is true. We're not saying like oh yeah, I hope that explains it. But for example, if we were like say 3 squared does not equal 9, that would be a false statement because we know that 3 squared does equal 9. Okie doke. Alright, so now, where was I? Alright, yeah. So 8 plus 4 does not equal 12 is the false statement, but 3 squared equals 9 is the true statement. And as we know, it's a disjunction, so it's or. So either of these can be true, and the disjunction would be true. So the disjunction, is true, because 3 squared does equal 9, which is true. So this is true. Okie doke. Alright. Where was I? Oh yeah. Okay. So now what do we see? We see the negation of Q is true, and P is still true. So because Q was false, that means that Q by itself was the statement 8 plus 4 does not equal 12. So Q negated, okay, Q negated means that 8 plus 4 does equal 12. Okay, so we know that. Now for P, it's still true, so P is still 3 squared equals 9. So both of these statements are true. So since they're both true, what does it make the disjunction? True. So we put true for this. Okie doke. Now, what if both the negation and the P are false? What do we do? Okay. So, because Q right here is true, that means that 8 plus 4 does equal 12. So Q, the negation of Q means 8 plus 4 does not equal 12. And P is false, so that means P is 3 squared, 3 squared does not equal 9. So both of these are false. Okay, so now the question becomes, is this disjunction true if both of the statements are false? And no, because one of the statements has to be true for a disjunction to be true. If both of them are false, then the disjunction is false. So we put false right here. Okay. Alright. I'm giving you a chance to figure out, consider the last disjunction. Consider it and try and figure out for yourself for a couple seconds what it could be. Okay. Alright, so we know that Q is false. So that means 8 plus 4 does not equal 12. So the negation of Q is 8 plus 4 does equal 12. And for P, that is false. So that means that 3 squared does not equal 9. So, we know that the negation is true, but the P is false. So, in a question of, is either of them true? Yes. So the disjunction is true, because one of them is true. Okay. I hope this is like a good basic explainer for like how to do a truth table. I will have more of these on how to do them like in increasingly harder ways, and like how to do like if you have more than 2 statements, how do you do it? Alright, see you soon.